Okay, this is the exponential functions and logarithmic functions review. I'm going to do some of these with you, and then you're responsible for the others. So on the first one, if we're solving for x, I would probably try to write both sides with the same base first. What base could we use? 4, right? How would I write 1/4 with a base of 4? 4 raised to the -1, right? And it already has an exponent of x. Well, remember, base, power to a power, keep the base, multiply the exponents together. So -1 times x is -x equals 4 squared. If my bases are equal, then my exponents must be equal. So -x equals 2. Is that my answer? What's your answer? X equals -2. Because I got to divide both sides by -1 to get -2. On number 3, what do you think? Both of my bases are the same. What do you think I would do there? If my bases are equal, then my exponents must be equal. Could y'all solve for x? Yes, no, maybe? Yes, I'm sure it's a basic simple equation. Just solve for x. Number 4, what could we write both sides with a base of what? I would say 3. We know 3 to the first is 3. 3 squared is 9. 3 cubed is 27. 3 to the fourth is 81, right? 3 to the fifth is 243. So I would say we could write both sides with a base of 3. So 243 is 3 to the 5th power. It already has an exponent of 2b, so don't forget it. Equals 81 is 3 to the 4th. It already has an exponent of -3v. So on both sides, my exponent had an exponent. So we use the power to a power rule. Keep the base, multiply the exponents together. So 5 times 2v is 10v equals, keep my base of 3, 4 times -3v is -12v. Keep the base, or I'm sorry, if my bases are equal, then my exponents must be equal. Did I make a mistake somewhere? I mean, do you see that I made a mistake somewhere? All right, well, I'll keep going because it says my answer should be 0, but that's not what I'm getting. Oh, I see why. I shouldn't have done that there. They both had a v with them. Scratch that. I should have added 12v to both sides. So 10v plus 12v is 22v equals 0 because I had v's on both sides, right? So if I get them together, divide both sides by 22, what's 0 divided by 22? 0. So I didn't make a mistake. Number 11. My bases are already equal. So if I set my exponents equal to each other, well, isn't -3x equal to -3x? Isn't that a true statement? Yeah. Negative 3x does equal negative 3x. So on that one, that's a true statement. Anything I substitute in for x, I would get the exact same thing on the left side as the right side. So right there, I don't need to do anything. My answer would be all real numbers. That's the only answer on the whole thing that's all real numbers. So don't just put that for all of your answers and think you're going to get full credit, because that's the only one there is. All right, let's look at the next section. Solve each equation. Round your answers to the nearest 10,000th place. On number 13, I can't worry about writing both sides with the same base yet because they're not in exponential form. What could I do to get number 13 in exponential form? Divide by negative 10. Exactly. Not add 10, because that negative 10 is being multiplied by 14, right?
Miss Rayleigh?
Yes?
Do you have Travis Douglas in class?
I do.
Can I go to this one, please?
Sure.
Thank you.
You're welcome. So y'all go ahead and divide both sides by negative 10. So I get 14 raised to the 3a equals 2.3. Can I write both sides with the same base? I can. How am I going to write 14 and 2.3 with base of what? So what do you think I would do? If it doesn't work in exponential form, well, let's write it in logarithmic form and see what we can do there. So that would be log base what? Nope. 14 of 2.3 equals 3a. Let's see, does 14 raised to the 3a equal 2.3? Is that what I have here? Make your little snail, right? 14 raised to the 3a equals 2.3. That's what it says, right? So now, can I use change of base on the left side to get a number? Okay, so remember, you got to put it in your calculator correctly. So you do log of 2.3. You must close parentheses or it's not going to evaluate it correctly. Divided by, and then you do log of whatever the base is. So log of 14. And I get approximately 0.3156. Equals 3a. Then I'll divide both sides by 3. And it said round to the nearest 10,000th place. So tenths, hundredths, thousandths, 10,000ths, that'll be 0.1052. Sorry, what? When I'm finished, I'll go back. You can look at this. What do you think I'm going to do on number 14 to start it off? Add 9.9 to both sides. So I get 18 raised to the negative p equals 5 plus 9.9 is 14.9. Can I write both sides with the same base? No. So if it's in exponential form and you can't write both sides with the same base, then the next thing you do, okay, well, let me try to write it in logarithmic form and see if I can do something there, okay? Because if you can't write both sides with the same base, that's the next thing you want to try. So you would do log base. Y'all tell me. 18 of 14.9 equals negative p. Can I use change of base on that? Yeah. So, and remember, it's important the order that you put in. What you put in the numerator and what you put in the denominator makes a difference. The base has to be in the denominator. So log of 14.9, close parentheses, divided by log of 18. It's approximately 0.9346 equals negative p. So is that my answer? No, because I can't leave p negative, right? So p is approximately negative 0.9346. Coolio? If y'all need to see these afterwards, you can look at my paper. I just want to move along. So on the back side, 21 through 24, you're just use a calculator to approximate. You're just using change of base. Okay? So just log of 3.8, close parentheses, divided by log of 3. Just change of base. Those should be easy. Everybody should get those. Everybody knows the order to put them in, right? Tell me now, because I'm not telling you on test day. So that would be log of 3.8, close parentheses, divided by log of 3, enter, and your answer should be 1.215.
So we don't need to write that out then?
No, you can just, on those, you can just give the answers. On the other ones, you need to show me your work.
Alright.
25 through 28, it just wants you to write it in exponential form. So currently, if it's in logarithmic form, and exponential form, just remember your little snail thing. So this would be what? (16) raised to the 1/2 equals 4. That's all. There's no variable. There's nothing to solve for. You're just converting the form. And 29 through 32, it's in exponential form. It just wants you to write it in logarithmic form. So 29 would be log base 12 of 12 equals 1. That's it. There's no variables. You're just rewriting the form. Okay? So while you're in class, I would save those that you don't need a calculator for. Save those for if you have time after class. Okay? Do the ones in class that you're going to need a calculator for if you don't have a calculator at home. Remember, if you don't, you can Google scientific calculator, graphing calculator, to get a log button. If you have a scientific calculator at home, usually you do it backwards from a logarithmic calculator. You know how logarithmic you put log and then the number? On a scientific calculator, you put the number and then log. It's kind of different. So look in your notes and look at a problem that we did and practice on your scientific calculator to make sure you get the right answer before you try and do all your homework with it. Okay? Anybody have any questions? No one's paying any attention to me, so. Okay.